Okay, this video here we'll just take a look at some basic brick detailing. So for the purpose of this discussion, I'll just use this picture, and just to start, what we're going to look at is this detail right here. So let's take a look at what happens at basically the brick at floor level. So this one here, the floor level is obviously up here, and they've extended it down a little bit. I'll show it a little bit different of a scenario where it's not being extended down. And as well, I'm not a fan of floating brick. So you'll see if I zoom in there that the brick is floating. I like a nice heavy cladding to sit, at least up here, it's sitting on a foundation. So we'll deal with that as well. Some other stuff you'll notice in this picture is, the control joint here. So you want to locate that. So that would be a soft caulk joint in there. And you want to locate that a certain distance from a corner. On one side, and then it's a little bit farther on the other side. Just have to do a little bit of homework on that from some brick associations, basically. And usually, what happens is at every floor level, you have a shelf angle holding the brick up. So basically, with that line you see there is a steel shelf angle holding the brick, and what that's doing is just making sure that there's not too much weight of the brick itself, bearing down on lower bricks and crushing them. So you typically would install a shelf angle at every floor level. However, I think brick can go a little bit higher, but usually the standard is to install them at every floor. So that's kind of what we're seeing right here. And it looks like they also did a shelf angle at the roof deck height, roughly right there. So again, I'll do other videos for for a typical detail there, and then a typical detail here. But for this video, we will just focus on, I guess, probably this situation right here, where the brick's pretty much at main floor height. We'll take a look at that scenario. I guess we can look at this too. We'll kind of cover both scenarios in this first discussion. So I'm going to start by showing how brick has been installed in a lot of buildings, like older buildings. We wouldn't do this today, so I've made that very clear. Do not do this. But you will find if you're renovating buildings, the approach of how the load of the bricks used to be transferred back to the structure was you would push the foundation wall out so that it would pick up the weight of the brick right there. So the loads of the brick would be coming down into this foundation wall. And usually the brick would just be positioned so that dimension's about 10 millimeters, just overhanging the foundation. That would just help deal with any imperfections in the face of the foundation wall, extending out past the brick, for example. So this has been done a lot on a lot of buildings, and I would say do not do it. And the reason being is there's no insulation here, basically. So I've assumed a slab on grade in this scenario. Okay, so here's our interior slab on grade, insulated below and insulated on the inside of the foundation wall. It's very common. I know you look at that and you're like, hopefully you're looking at that and saying, wow, but that's how it was done. And I've shown an outside insulated wall right here. And so obviously the issue here is there's no insulation through this building right here. There's no continuity of the insulation. So that's a problem. So we certainly wouldn't want to do that today. And likewise, you might find a situation, nowadays where there is insulation on the outside of a building, or even older ones. That's fantastic if they actually did that. But again, this doesn't do us any favors here because you still have no insulation through here like that. So there's still a big problem there. And so here's an example of what I just explained. So this building here, I can pretty much tell that brick is sitting on the foundation wall right there. And so now another situation you might see is something kind of like this, where the foundation wall is pulled back and the brick now loads onto a steel angle. Okay, so same issue. So that's fine. The loads are carried back to the foundation, but the problem is, again, you have no insulation through here. The second problem that I have with this is you have that scenario of floating brick. I personally can't stand it when brick's floating above ground, just kind of hanging there. So that's the other issue with that one. And sometimes you'll see this scenario where, okay, there is insulation added here, which might appear good, but again, don't be fooled by that. The issue is you have continuous steel with high conductance going from outside to inside. So you would be having an enormous amount of heat loss through there like that. So there is a way to avoid this as well. And so just to draw something similar to what we just saw, here's an example of, the steel angle right here being bolted right to the foundation wall. So obviously this is a slab on grade building and there's no insulation here. So even if you put insulation, between here and here, you still have the issue of this steel going right through the insulation. So not a good approach. And again, the floating brick is not super desirable either. And so I'm going to put a big X through that one. Don't like it. And I'm going to put an X through that one. Don't like it. Okay, so here's what we can do to make a pretty good modern detail with some good thermal bridging reduction here. So slab on grade again, insulated onto the slab, insulated on the inside of the foundation. So this is no basement here. It'd be a wall and footing or a grade beam and pile or something like that. And I've done full outside insulation on this building, so there's the brick right there. And we're going to adopt that idea of doing the shelf angle holding the brick up. Okay, so ideally you line up your face of grade beam with the face of sheathing right there. That's an ideal situation. And then we have the outside insulation put on there. And the brick becomes pretty far away from the foundation wall. So again, we don't want to take an angle. We don't want to take an angle and do this. That's not a good idea. Okay, because we still have heat loss through the steel on that angle. So the idea is let's just do an angle right there. Okay, and then we'll use a knife plate. So this dashed line represents a knife plate, which ties the steel angle, the continuous steel angle here, back to the foundation wall, and it can just be welded to a plate that's embedded in a steel plate that's embedded into the concrete. And so here's a picture of this idea. So this one happens to have a upturned steel angle, so it's like that. But the point is it's not going all the way back to the concrete as a continuous angle. What's been done here is knife plates have been added. So that's what I dashed in the details, these knife plates that are roughly 1200 on center or something like that. And so what this allows us to do is to fit insulation between the angle and the foundation wall. And then you have far less thermal bridging happening at these locations. And to boot, you could actually thermally break these connections as well by doing two plates with a neoprene gasket between them and then bolt through or whatever. But that ability is there, but certainly what you're seeing right here is a good improvement to just running an angle back to the foundation. And so in this picture here, you see how the insulation now is being fitted in behind that steel angle, which is fantastic. And then there'd be, we'll get into the flashing and all this right here, but there'd be the mineral wool probably insulation for the upper portion of the wall coming down to the flashing there. I mean, this is a little bit different scenario. This is a plaza deck right here, so there's a parkade below there, but a very, very similar situation. And so now I've turned this angle down as opposed to what you saw in the picture there. This angle is just turned down, and that's so that it has something to attach to. Like if the angle was turned up, if the angle was like this, you could do that. But when you put the knife plate in, you got nothing to attach to right there, so you'd have to do something to attach that. So you'd probably end up adding a piece of steel in there, that's going to go through your wall or what have you. Or, probably the best way to do it would be you'd have a HSS steel tube sitting there like that, and then the knife plate coming out like that. Why? When we can just turn the angle down in this scenario. And just to show kind of that idea, I'll show a picture here. So I just stumbled across this shelf angle being installed on a building where they kind of took that approach, but they didn't even do a knife plate, which kind of sucks. There's even more steel going to go through the insulation. But, I guess in this case, I don't know the history of this building. Why didn't they just turn that angle down in this case and attach to the wall right there? Probably because this is a plaza deck as well. I think there's a parkade under there, and they just didn't have room probably to make it happen. But anyways, you'd be looking at something like that if if you turn that angle up. So we'll just keep it turned down because that works out much better. Okay, so let's just run through what else we see happening here. So again, slab on grade, insulated underneath, and insulation right there. So there would be a vapor barrier installed on the warm side of that insulation underneath the slab. In past buildings, you might not find that vapor barrier there, but we need that for radon gas control. So that vapor barrier would go in there, and in this case, I would just seal it to the concrete right there, because there's nowhere to tie it into basically. If by chance, this was an insulated stud wall, you could realign this joint right here, so that maybe I'll just draw it like this. If let's just say this was the finished gypsum board right there, then obviously if you insulate it in the stud space at that point like that, you'd want to have a vapor barrier on the inside, and then in that case you could certainly run a vapor barrier continuously around like that, so an air and vapor barrier. But a lot of times it doesn't work out that way, especially with an outside insulated building. So in this case, I would just stop it and seal it right there. So here's the bottom track of the stud, and what I'm showing underneath there, that purple dashed line, is a foam moisture separator, moisture barrier, I guess I'll call it. And so here's an image of that right there. So there's that moisture foam pad that's separating the bottom track of the studs from the concrete, because the concrete can have moisture in it. You don't want corrosion basically between the steel and the concrete. Actually, incidentally, here they also have the downturned steel angle. Nice. Okay, so what else I have drawn here is, you wouldn't want the gypsum board right against the concrete and as well the sheathing. So I've just drawn in like a caulk joint there. So it's usually a little gap. You can just caulk that gap. Now the idea of these full bed brick systems is, there's an air cavity in behind. So there's an air cavity right here. I'll get to that purple thing in a second. And we've done an outside insulated building, so we're going to have an air, vapor, and moisture barrier on this building. So what I've shown here is a starter strip of air, vapor, moisture barrier, and basically that's going to go on first and then overlap whatever it is we're going to do on the foundation right there. So we'll get to that in a minute, but I've drawn a starter strip of that, kind of doing that right there. And then I've got another layer overlapping that one and then overlapping this flashing, which I'll get to in a sec. And so what I'm after there is ensuring continuity of the air barrier. So by overlapping the two right there, you have continuity of the air barrier. Because if you just did this, then theoretically you wouldn't have continuity of the air barrier. So that membrane is the air control layer. So overlapping them there is a good idea. So I like to show that. And then of course it overlaps the flashing. So the orange there is the flashing. Okay, and having a drip edge on there is important. And if a 45 kick is pretty good, and it can be sharp. So if it's going to be a place where people could cut themselves, you could do a hemmed seam, which looks kind of like that. I have shown weep holes here. Okay, so the bottom brick, well, not the brick, but the mortar between the bottom row of bricks. Every 400 on center, you'll have weep holes so that any moisture that gets either back here can find its way out, or any moisture that comes down in the cavity can find its way out, or any moisture that comes down the back face of the brick can find its way out. So there needs to be some holes for that to weep out. And so just taking a look at that here, there's a shelf angle here, right there in this wall, and if we look down at the bottom here, we'll see the weep holes down here. So there's a weep hole there, there's one behind there, and so on and so forth. So there's weep holes at 400 on center, and at the top of this, so again, remember that this shelf angle here would cut off a cavity, this cavity behind this brick from this one here. So there's vent holes at the top as well. Okay, so this block of brick, there's a weep holes at the bottom of the cavity and vent holes at the top, which you can see there. And then, of course, on top of the angle, there's weep holes again, and so on and so forth. So the idea there is, air circulation can get in behind the brick to dry out the back of the brick, but it also allows any moisture to trickle out of there if need be. Thirdly, it'll allow pressure equalization of the cavity to the exterior. I wouldn't say it's going to be a pretty slow process, maybe, because there's not a lot of big gaps there, but ultimately you'd like to have pressure equalized air in the cavity to the air outside the brick. So the airflow behind there will facilitate that. And so anyways, that's how I've seen weep holes, typically indicated just an X through the bottom brick with a note just saying weep holes at 400 on center or something like that. This purple right here is the mortar dropping net. So as the bricks get stacked with mortar between them as you go up, some of it can fall in behind. So you want to make sure that's not clogging the air cavity back here. And so I don't have a picture of that, but I just did a quick search on the internet here, and you'll see, it's just like a foam or wiry type insert that goes in the cavity that allows water to flow through it and get to the weep holes without the mortar clogging it, basically. So that would be an important feature to add into your detail as well, and make sure it's in your specifications. And so, as I mentioned, this is a knife plate here, so now we can extend our insulation in between those knife plates and have less thermal bridging issues there. And finally, to deal with the floating brick look, which I personally don't like, what I've put here, what I've shown here, is a concrete faced insulation board. Okay, it could just be like an XPS insulation with a mesh put on there and parging put on there, but you can get a concrete faced insulation board which looks pretty good. And so here's what that looks like here. So it's just like an XPS insulation with a thin concrete facing applied to it already. And it looks like in the background there it's actually installed. So all you really get, it looks like a foundation, like to the untrained eye, but you do get some lines in it. But it's a pretty nice product. Here's an image of a not so perfect install, but you get the idea here. So there's a limestone full bed brick veneer there, with the flashing sticking out, and there's that concrete faced insulation board. And what's giving it away is when I looked close, I could see the insulation right there and the thin face of concrete. So it didn't quite get finished off too well on the corner there, but otherwise, from out front looking at this, it looks pretty good. You got a heavyweight brick veneer cladding sitting on something, and most people would identify that as a foundation right there. And so the only thing left to talk about here is, obviously you'd slope the sidewalk away. The other good thing actually about making sure you don't have your sidewalk underneath the cladding, even though this is a steel angle and brick, if it's an EAF system or whatever, a lightweight cladding, sidewalks can heave, and if they heave, they can put a lot of pressure on this, and they could bend that and crack the brick. And if you have a lightweight cladding, then it's even easier for it to do damage to the cladding. So I've seen that happen, and you want to avoid that. So I tend to like to get the sidewalk out from the face of the cladding to avoid that frost heaving happening. So the only other thing we haven't talked about here is what is this purple dashed line right there. So that could be many things. So again, this is a slab on grade, so there's no basement over here. It's just there would be a compacted granular fill here, and then just dirt basically. So what would that purple line be? Like, what would that be right there? It could just be damp proofing. It would probably be okay. If you wanted to take it up a notch, you could put a self-adhering air vapor moisture barrier on there. You don't, unless you had a really high water table or something happening, you wouldn't really need a drain board on there, but certainly it could be something that could be done as well if you really wanted to pimp it out, basically. But I would say the least would be damp proofing. Probably the reasonable scenario would be to do another layer of self-adhering air vapor moisture barrier. And what that's really doing is just making sure that there's no moisture getting into the concrete and migrating up through the concrete through capillary action to, I guess we have protection to our metal studs there, but if there's a linoleum flooring finish or something in here, it can start to make it bubble and stuff like that. So you want to avoid that. So that would be, that'd be your options kind of down here. I don't think it's a super critical situation in most cases, but at the very least, I would do some damp proofing there. And that's a pretty solid detail at the base of brick. I've shown mineral wool on the upper walls. That's usually what's used, and then XPS insulations tend to be used below grade, but you could do mineral wool and it could be EPS as well, but generally you'll see XPS insulation being used. And one last thing to mention here, what if the sidewalk is much lower? Okay, so what if the sidewalk is down here, like we see in this image here? So the floor level is obviously right here. So we've done kind of that detail there. All you do in this case is you just drop the shelf angle down, and you want to obviously make that drop equal to full beds of masonry. So in this case here, it looks like they did three courses, so it'd be about 200 millimeters. And all that would mean for this detail is that this shelf angle now would just drop down to wherever you need it to be, really. So maybe it's there. And you just add some more bricks in there, like so, whatever works out. But that's all it would take.